So, e to the I pi equals -1.
I'm going to try to explain what this weird equation even means. Well, first of all, let me try to explain what the e to the I pi even means. Even though e to the 3 I pi, e to the 5 I pi, e to the 7 I pi, and so on all have the same answer. So let's start off simple. E to the x. Actually, for all you dumb let's start even simpler. 2 to the x. If you think 2 to the x is 2 multiplied by itself x times, you're wrong. Because it's really this thing. Why? Because how the do we figure out what 2 to the 2.17 is? Exactly. You can't multiply something together 2.17 times. That's why you have to use my good formula here. Here, since you still have no idea what I'm talking about, I'll run through 2 to the 3rd power. Okay, so the natural log of 2 is 0.693 yada yada yada. Okay, now your exponent x is 3. 3 times the natural log of 2 is 2.079 yada yada yada. Okay, for the first iteration, n is equal to 1.
So you don't change this for the first iteration.
Oh yeah, you don't know what iteration means because you're a dumb. An iteration is just one in a sequence of steps you take in order to reach some final value. Moving on. So, you add 1 to 2.079 to get 3.079. Did you understand that? The after the decimal point doesn't matter since you're adding a 1. Okay, now you raise this final number to n. 1. So you don't change it, and that's the final value.
Oh wait!
Did you forget this term? Because I sure as did.
So,
You do all that previous but for n equals 2. 2.079 divided by 2 is 1.039 yada yada yada. 1 plus 1.039 is 2.039. Raise this thing to the 2nd power, and we have our 2nd iteration. Okay, so how do we raise something to a power? Okay, so it's 4.061. The 3rd iteration turns out to be 4.853. The 10th iteration is 6.614, and the 500th iteration is 7.965. You see how these numbers are getting close to the final answer of 8? Therefore, 2 to the 3 is 8. Simple enough. Now, let's move on to e to the I pi. To simplify things, let's just take e to the pi. Since the natural log of e is just 1, this equation turns into this. Okay, pi divided by 1 is just pi, right? Right? Yeah, so let's add a 1 to this. Did you get 4.415 and so on? Good job! Let's raise this to the 1st power to get a final answer of 4.145. Close enough. Okay, you know how to do the rest of this long process, so I'll just tell you what happens. The 10th iteration is 15.363. The 1000th iteration is 23.0270. Can you see how all these values converge to 23.1407 and so on? No? Well, you're a f***ing idiot. Wait, this doesn't help at all. Okay, e to the I pi. If you plug in I pi to this equation, what do you get? Well, for this big part, you get 1 plus pi I. Since you just raised this value to the 1st, this is your 1st iteration. Congratulations, dumb. You're 1 over infinity of the way there. Now this is where it gets a little more complicated for your primal basic brain. For n equals 2, this part turns into 1 plus pi over 2i. Okay, now how do you take this number to the 2nd power? 1, you could type it into any calculator made after 1980, or you could do it the fun way. I may or may not make another video on complex number operations, but for the sake of already having a long script, I'll show you how to geometrically raise a complex number to certain powers. Wait, You don't know what complex numbers are? Well, go take a year 8 algebra course, you idiot. Anyway, so you plot the certain complex number, right? Now you draw some straight lines here, here, and here. To raise this basic number to, for example, 3, you take this same triangle, put these corners on top of each other, rotate the triangle so these edges line up, and scale the triangle from this point so that this point lies on top of this point. Okay, so if you do this again with this triangle, because we want the third power, right? Okay, so now this point is on our answer. If you make this initial complex number 1 plus pi over 2i and raise it to the second power, you get negative 1.47 plus 3.14i. Good. That's only our second iteration. Now for the third. If you're intelligent enough to see the pattern here, you would just know that the next starting point is 1 plus pi over 3i. Okay, if you raise this to the third power using all that triangle I just freaking showed you how to do, you get negative 2.29 plus 1.99i. Are you seeing the pattern? Because I sure as don't. Let's do higher iterations because we're lazy and don't want to see the pattern emerge slowly. Okay, the 10th iteration is negative 1.56 plus 0.16i. The 10th iteration is negative 1.051 plus 0.001i. Pattern C? The 1000th iteration is negative 1.0049 plus 0.00001i. Do you see it? The real values approach 1 and the imaginary value goes to 0. So yeah, e to the I pi equals negative 1.